Hello guys, welcome to Chemistry World, and today's the topic of our lecture is sulfonation of benzene in aromatic substitution reactions. So first of all, we have to see the reaction of sulfonation of benzene. The general reaction we use is, here we have a benzene ring. It can react with SO3 plus H2SO4, and we can get HSO3 plus H2SO4, the catalyst return to its original position. So it is our reaction. The second method of this reaction is we can take H2SO4 instead of SO3, H2SO4 here, and in the catalyst also H2SO4, and we can get our sulfonated benzene ring plus H3O positive plus H2SO4. Sorry, not this one. So it is our second method of sulfonation. So as we already know that in aromatic substitution reactions there are three methods of mechanism. So the first method is making of an electrophile. So here in sulfonation our electrophile is SO3 positive, making of electrophile. Electrophile means electron loving species. So the question is why our electrophile is SO3, how it is electropositive and electron loving. So the answer to this question is S is surrounded by 3 electronegative oxygens, and the second one is here. That's why it is more electronegative, more electropositive. It is 3 times electropositive here as is. So how to make SO3 for sulfonation? First method is the reaction of H2SO4 with H2SO4. H2SO4 plus, we can write it as follows, SO4. As we know that the oxygen contain electron pair, it attack on the H of second H2SO4, and we can get H3O positive plus SO3 positive plus HSO4 negative. Here we have 2 electrophiles. The first one is H3O positive and the second one is SO3 positive. But the benzene ring attacks on SO3 positive because it is more electropositive instead of H3O positive. And the second method is the reaction of SO3 with the catalyst H2SO4. The electron pair on the oxygen attacks on H of the H2SO4 and become HSO3 negative positive plus HSO4 negative. So there are in the second method our electrophile is HSO3 positive. So the second step is making of pi and sigma complex. second step is making of, so the second method for the making of electrophile is more used because it produces more SO3, more electrophiles than the first method. The second step is making of pi and sigma complex. So the benzene ring attacks on SO3 if we use the first method of electrophile, SO3 positive in this way, and forms pi complex. It is a transition state not present for a long time. Transition state, and after a while it converts it into sigma complex, which is an intermediate state. We can write it as follows because it is a resonating structure. SO3, now the positive is come here and H here. So when SO3 is attached with the benzene ring, it is negatively signed because oxygen is electronegative in that. So it is resonating. How it is resonating? If we make it as if the positive is here because of SO3 and here H, it will convert itself into this state, the positive here, and SO3 here and H here. It is again converted into another resonating structure. The positive is here, the pi bonds are here and here, SO3 and H. So instead of these three resonating structures, we can write it as in this way. Now the third method is removal of H positive, this H positive from sigma complex, which is intermediate state. It is sigma complex intermediate state. We can write it here, sigma complex intermediate. Now we have to remove H positive. The third step is we can make removal of H positive. Removal of H positive from sigma complex. As we already know that we have HSO3 negative, HSO3 negative, HSO4 negative, sorry. It attacks on the H, here SO3 negative and here is H. So its oxygen attacks on this H and we can get SO3 negative plus H2SO4, but we also have H3O positive, which we make in step number 1. here we have H3O positive, so the SO3 minus attacks on this positive and will become our product, which is SO3H. So it is sulfonation of benzene ring. If we start the reaction, if we write this reaction from step number 1, from method number 1, from this method, this SO3 attacks on a nucleophile in step number 2 in this way and form pi complex and sigma complex, and the reaction begins and end to give us this product. If we write this reaction with second method of making electrophile, then we have HSO3 as a catalyst, as a electrophile, HSO3 as an electrophile, and we also have HSO4 minus. So if a benzene ring is here, and HSO3 3 positive is here, then benzene ring attacks on HSO3 positive and will become, now it is your assignment to make pi and sigma complex. I can't because it is time consuming. Here HSO3 SO3, where is razor, SO3H, and the H from this side will attack, if it is pi complex, then the H will attacked by HSO4 negative, which is made when we make this electrophile in step number 1. So this attacks on the H and the reaction becomes, here we have H2SO4, the catalyst returned to its original position, and either SO3H. So it is our second method of sulfonation from second method of making electrophile. So there are two methods of making an electrophile. First one is the reaction of H2SO4 with H2SO4. It will give H3O positive, SO3 positive, and HSO4 negative. The second, in second method, we have SO3 plus H2SO4, and we get HSO3 positive plus HSO4 negative. Both the mechanism are given below. Here the benzene attacks on SO3 and become pi complex, then sigma complex, which is electropositive, which is resonating in intermediate state, and then removal of H. If we use second method, then as HSO3 is attacked by a nucleophile and become sigma complex, and here HSO4 negative attacks on the H and become H2SO4, and we can get our product. So these are two methods we have discussed for the mechanism of sulfonation. I hope that you guys are enjoying this video lecture. If you like that lecture, please subscribe, like, and share. Thanks.